Very welcome.
My name is Jason Perry. I'm the Senior Manufacturing Engineer for Tecomet. I was the first engineer actually hired when this company was still Everest Metal. Initially in 2004, the site was set up for surface finishing processes for one specific customer. That expanded over the years from transferring other production cells from other sites, other companies, new product introductions. Between 2006 and 2008, Symmetry Medical took over the company and expanded operations in each site. Come 2014, Tecomet bought out Symmetry Medical, which now has 16 sites globally, including Cork, the best, Sheffield in the UK, Lille in France, and Penang in Malaysia. All the other sites are in the States. Initially, I'd previously looked at SW machine tools for a cobalt chrome tibial tray cell in the other building in the facility to handle volumes. Unfortunately, that didn't materialise due to different volume constraints. But you know, we were happy with what SW had shown us at that time, and I'd always been looking at those machines in the background. So when the high volume plastics production opportunity came up, I put that out as an opportunity. We contacted SW and they came over and we did presentations, we had many discussions, and we sort of built up the user requirement spec for the machine based on what capabilities were there and took it from there. Even despite the pandemic, once we'd laid out the user requirement spec, that laid out all requirements for the products, the capacity that we needed to try and achieve, quality implications that were there, whether it's dimensional, profile, visual tolerances, everything had to be met within that, which then went towards building an easy validation process. But even though we had a similar process running already, when we transferred it to this machine for the volume size of it, SW made sure everything was working as it should be. The team was a bit sceptical about ordering a machine that was never seen live, purely because there was no confidence there. But with following the factory acceptance test and the results we got back from there, showing the capability, the repeatability of the machine, I think that's an easy sell. That sold itself. For commissioning, obviously we went through the qualifications and factory acceptance test. We do have, being a medical device manufacturing facility, we do have very high standards of what we need to achieve with obviously the quality side of things. Dimensional profile tolerances have to be consistent. We have to be able to run this on a minimum crew. So all this was expected as part of it, and that was delivered. Okay, well, once we'd actually got through the qualifications of the machine and the testing, the site acceptance testing, the machine was up to full capability within 4 weeks. Handling the machine has been a dream because it's such a simple user interface to train people. There's very little goes wrong with it. We have great service back from SW. So that's all that, which was also built into part of the user requirement spec. And that's one of the important things when you're actually buying machines, is the service backup you do get. And that's been absolutely top notch. These particular machines are great. They have high spindle speeds, the linear box guides. The horizontal spindle orientation has a great impact because all the swarf then falls into the bottom of the machine, into the tray, and is taken away, so you have no build up on the parts which can get embedded into the products. So there's an operator has the freedom to be able to continue running the machine, setting the machine up while this part's being inspected. As per operator, we're probably up about 8% per operator compared to other machines within the cell. Yeah, tool presetting was going to be a challenge. So we've standardised tool holders, the way a tool setting method, because obviously we've got no adjustment on with the same tool on each spindle. So we've come up with a simplified process to actually make sure that tools are all the same length. But we've come up with a good system and it's very repeatable. The first of the BA machine sensors came on site in 2022. The first machine was integrated into the cell in 2022, and the second one followed a year after in 2023. We had to achieve a high volume output, and that was one of the main factors. The main reasons for choosing the SW's multi-spindle machines was spindle speeds, cycle times, the tool change speed, the 5-axis capability, spindle orientation, footprint and output. Within this product range, there's 10 different sizes and 8 different thicknesses. We use quick changeover jaws for fast changes between sizes, and the fixtures themselves are manufactured within the machine, so they all have the same reference points and datum points, which is crucial because as there's no other adjustment between the spindles, at least we know the fixtures are manufactured within the machine scope. It's not just time, it's actual capacity. We've got 2 parts coming out of the machine at any one given time. This reduces any interaction time that the operator needs to have with the parts or with the machine. Parts can be set up while there's already 2 in cut, even during sort of opposite fixture setup, and that's why we have an OEE up in the mid-90s. Okay, compared to some of the other single spindle 5-axis machines have on the floor, these are approximately the same size, so they're a very tidy footprint. Initially, there were concerns over having a multi-spindle machine on the floor, but I think once we got through the factory acceptance test and the site acceptance test and the validation, I think that proved itself. Initially, there were concerns over having a twin-spindle machine because there's no flexibility to change the offsets from spindle to spindle. But over time and after the site acceptance testing, I think that proves not to be the case. Okay, setup time from product to product is approximately 6 minutes because you can still be setting up while the machine is machining the final parts within the previous batch.